Hello, welcome everyone to another episode of ZEISS Microminute from our ZEISS Microscopy Customer Center live. I am 𝗶𝗶𝗃𝗀𝗀, I am Applications Engineer, and the today topic is precision in water purification, a multi-scale approach to microbead characterization. Please scan the QR code that you are seeing on your screen now. Okay, you can scan the QR code that you are seeing in your screen now to see their upcoming episodes. The next episode is next week, February 13, and it's a really interesting topic about EVO, our system, conventional SEM, conventional scanning electron microscope, and will be very, very funny topic about 21st birthday. Yeah, please sign up on our next Microminute. Okay. This is me. This is David from ZEISS Innovation Center, California. We are located on this side of the building. Our microscopy customer center is here in this side of the building. Yeah, and now let's start with the Microminute topic today. Please don't forget, if you have any question, only put your question in the chat and I will be glad to answer your question at the end of this session. Yeah, right now, let's start with this topic today. The topic today is about water purification. It's a very interesting topic, yeah, very impactful topic. I would like to introduce some technologies that is important or have a lot of benefits, how to characterize this kind of materials. Okay, let's go. Let me go further. This is the main reason we are discussing today this topic. The important thing is 2.2 billion people, according with Water.org. This is an organization that have many different measurements, many different facts about water around the world, about the access to water around the world. For many, many people, many population is lacking for water, and 2.2 billion people is lacking of safely managed water. That means 1 out of 4 person around the world is lacking of safely managed water. We are see what it means that exactly, but the other important thing here, the other important statement is more than 700 million people is lacking of basic water, which means 1 in 11 people is lack of basic water. What exactly this mean in drinking water ladder? I mean, if you have in your home or in your work or in your daily basis safely well managed, that means that you have access to an improved drinking water so that is located in the premises and available whenever you need, and it's free from contamination. That means you open you have open access to the water, a clean water. You are this part of the ladder. Otherwise, you probably have basic, limited, unimproved, or only surface water. We are talking that more than or around 2.2 million people will have safe managed water. I mean, if you have, for example, access to improved water, but you have to collect that water in less than 30 minutes, that means you are cataloged as basic water access. If you need to move more than 30 minutes in a round trip to collect improved water, that means you are limited water. And of course, unimproved water, that means that you drink water that came from a protected dog or spring. I mean, that is no treated water before you access of that. And surface water is if you are getting water from a river, dam lake, or a canal. That's the differentiation in the ladder of the access water from different kind of population. That's why it's so important to investigate different ways to clean water and have more accessible to everyone. That what is the ecosystem right now for the water? I mean, the body waters have been contaminated along the story for different ways. I mean, every single activity of the human do it right now have an impact in the environment, and of course have an impact in the water that you are consuming right now. And of course, that kind of emerging contaminant that you can find in different body waters can have adverse effects on crops, have impact negative effects on food chains or aquatic species. Some of these emerging contaminants that we can find in many body waters can be drugs waste or medication waste, bacteria, of course, and industrial dyes, and many other different. To try to solve that, currently we have some sustainable, or we are looking for, I mean, many people is working around this. Some colleagues, for example, work on sustainable, innovative alternatives that is needed to complement current methods for water treatment. For that, we use the people who investigate this made this kind of microspheres made from different kind of polymers. Alginate is one of them. The alginate came from an algae that can be found in the seas, and it's like a seagrass. And of course, the important thing here is to get that microbeads, but the other important thing here is what is the reaction in the surface of this kind of materials. I mean, how this can trap and collect this kind of contaminants. That is a very important topic to take in account when you are creating or you are investigating this kind of materials. Then we have three different or important takeaways here. Important thing: surface analysis. The material, this kind of materials will have an absorption surface. Then we need to investigate what is the surface component and how the surface looks like. That is other important thing is a multiscale characterization. In this example, we have centimeters diameter particles, but the other important thing here is we are even more interested in the very, very near surface material. I mean, how the surface looks like and how this catalytic surface will be act to trap this kind of contaminant. The other important topic here, which is very important for the topic that we are discussing today, is the material itself. As you can probably know, the electron microscope works very well with conducting materials, but we have here polymer, which is non-conducting material. And take that in your mind, because this is important for the topic today. This is probably the three most important topic: surface analysis, multiscales, and non-conducting material. And let's right now see what these kind of particles look like and what is the benefit of these particles. In this video that you are seeing here, this is how the filters look like, and how a proposal of this filter look like. Here you can see the particles. Here you can see the water, the water, for example. And this is how the clean water looks like after it's filtered. That is a very simple way, and it's accessible for many kind of population. You don't need a real high technology. I mean, the real high technology is behind doing this kind of material, but this material is accessible for almost everyone. Okay, right now let me show you how we are going to characterize this material. This is me in the lab. Right now you are seeing the AxioZoom microscope, which is a kind of stereo microscope. You are seeing right now the particles here. We only put the particles on carbon stop here, and that's it. We haven't to create any kind of further preparation here. Right now in the software, we are only adjusting the light for the microscope, which means is we need the proper light, the proper exposure time to create a real good imaging here. Right now we are collecting using a ZEISS. We have, remember, a sphere, and the sphere have different focal planes. In that context, we are creating a ZEISS. The ZEISS allows me to create different focal planes and compact this focal plane in only one image. And that's the purpose here, to create a big overview for different multiscale evaluation. This is the first step of the experiment. Right now, the system is collecting the full stack of image that we create with the AxioZoom. And after that, after the system collect automatically all these 90 slides, we can put together all in only one stack, only one image, extended depth of focus. We are called that as extended depth of focus, right? Right now, we have that image, and after that, we are collecting the ZEISS. This is me now on the Sigma now. This is the electron microscope. Right now, we are putting the same sample holder with any further preparation. We haven't to spotted coding this, and to start the imaging now in the scanning electron microscope. Before to start, we are right now open the image that we previously collected from the AxioZoom, from the stereo microscope. And right now we are collecting the very first image, which is very useful to create the first correlation. We need to correlate the information that we collect from the light microscope and now correlate with the electron microscope. To do that, we only collect the scanning, this first scanning, this overview scanning, and after that, we are doing the alignment. To do that, we only have to start with the alignment in ZEN Connect. And now we are only using the pin. This is a tool that we have here. And with the two pins that we create here from the translate, rotate, add scale, and share, we can correct the share that we have from different tools from two different sources. Remember, in the stereo we have light, and here we have electrons. After that, we are free to navigate through our sample using our light microscope image from reference. And right now we are sitting in the right position that we want, and we can start to imaging. Please notice in the very top part of this image that you can see the kilovoltage that we are using, the accelerator voltage that we are using. We are using here high vacuum condition and 1 kilovolts. And we have total free of any kind of charging effects here, which is really good to investigate this kind of imaging. Remember, we have in here polymers, and we don't have any coating over these polymers. Then the Sigma using 1 kV and high vacuum condition is able to explore and acquire free charging conditions, free charging imaging for this polymer. Right now, we are increasing our MAC because we want to investigate what is happening in the surface of the material. We want to investigate how this nanosphere that is attached to the surface of the material looks like, what is the dispersion of these materials, what is the porosity of the material, and we not only acquiring the characterization of the big diameter of the big particle here. We are now characterizing different multiscales right now. After we collect the information, right now we can now navigate through type Google Maps, a Google Map type imaging. We can create this kind of project here. To do that, we only need to jump now to the next workbench. Right now we already collect the very first image, the second image, and the third image, which is really high magnification. You can see the different pixels and the different information that we can store here. And this is really nice to have. You can even correlate image that came from a smartphone, for example, or from another different sources. That is another feature that we have in ZEN Connect. To do that, we only import that image that we collect in a smartphone, for example, and we did the same. We only align and resize this image, and now we can create a video. This feature is also included in ZEN Connect, and we can create that kind of project that you are seeing right now after you only select the frame that you want to acquire in your video, and automatically the software will create this every single frames, and you have this final result here. That is a real way to correlate and have different information from different instruments in a different context. That's the information for today. If you have any question today, please only put your question in the chat. I will be glad to answer your question. This is a real good story, how to create this kind of works, this kind of videos. And of course, if you have another different samples, you can do it the same. If you have different kind of artifacts, if you have other microscope, if you have another information that came from cameras or other, you can import it, and you can create this kind of project, of course. Right now, let me see if we have any question. We don't have any questions so far. Right now, let me move on to this. This is an important reminder. Please scan this QR code that we have here. In the left side, you can scan this QR code to see what is the incoming workshop. We have different kind of workshop for different microscopy techniques. We have light microscopy, electron microscopy, and X-ray microscopy, and we have different workshops. If you want to learn more about different techniques, you want to get more training for ZEISS instruments, you can scan this QR and you can see the incoming workshop. In the center, you can scan that QR and you can have access to the ZEISS portal. A lot of different topics that you can have there, information about the products. And in this QR, you can scan it and have access to the next coming live stream that we have. Remember, every single Thursday, we have this ZEISS micro minutes, very interesting with different kind of topics. Okay, let me see. Yeah, we don't have any questions so far. Please join us in the next micro minutes. I will be happy to see you around here. And yeah, my colleagues also will be coming for more fun topics. And please subscribe.